Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and welcome to a beautiful, warm, and sunny evening here in Pretoria, South Africa. Well, today I can tell you, I'm excited. I'm excited when I do mathematics. But I really want to welcome you and thank you for you giving your evening to listen to me trying to help you with trigonometry. Now, trigonometry, ladies and gentlemen, is truly one of my favorite sections of work in all of mathematics. Because when you start applying trigonometry in the real world, it's super awesome. Now, I'm not going to go into that too much because I might just get stuck for the whole evening. I love trigonometry and all the places where you can apply it. But again, welcome. So how is it going to work tonight? I'm going to try in our 45 minutes to, hour long that we have. I'm going to work through some exam questions, as you might have seen I do on some of my live sessions. But what I'm going to do is also just maybe, recap a little bit on some of the theory you need to be able to master trigonometry. But I do want to say, unfortunately, I can't go through all the theory, the whole cast diagram and all of those things. I'm just going to skim over the top of it just for the sake of time. If you haven't watched the previous videos that is about the theory and a lot more nitty-gritty things, good ways of thinking about trigonometry may be a bit different than you're used to, please go and watch those videos on the Junior Techies website or the YouTube channel. Now, what is going to happen is I'm going to display a problem for you, and I encourage you to hit that pause button and try it yourself. Or if you are not comfortable with your trig yet, just watch. Watch and enjoy, maybe make a few notes on the side. Please feel free to hit the pause button and maybe carry on. The feed is not going to stop. And afterwards, I'm going to, in any case, put this live session on our YouTube channel. So buckle up. Let's dig into the first example that we are going to do. So this first example we are going to do is a simple simplification. So what I'm going to do is, let's just read the question. Simplify the expression below to a single trigonometric ratio without the use of a calculator. Now, first of all, I want to say thank you to the people from St. Stithians Girls College for this beautiful question. Now, if they are asking me to simplify into a single trigonometric ratio, well, also without a calculator, that's a beautiful part. I basically have always two steps. And my first two steps are always the same. So my first step is always going to be, number one, I want the angles between 0 and 360 degrees. That's my step one. My step two, after I've done that, is I'm going to look to get my angles between 0 as between 0 and 90. Now, this is a fun part because no matter what they ask, it's about half of the question. Half of the marks, because this one counted 8 marks if I'm not mistaken, half of the marks or even more is simply for doing the first two steps. So let's start with the first step. Okay? Which angle is not between 0 and 360? That angle there by the tan X, let me rather underline it. And that one there. Those two are not between 0 and 360. So I'm going to first of all handle it. And interestingly enough, I'm going to handle it in two different ways, just because of the type of sums. The moment I see x minus 180 degrees, I personally like to add 360 degrees to that. Because if I add 360 degrees, I am going to get, so here's my attempt, I am going to get tan of x plus 180 degrees. That is perfect with me. Personally, that's perfect because that is third quadrant. So now that I can handle. But the negative x, if I see an angle like tan of negative x, I like to handle it as if it is in the fourth quadrant. And that means that tan automatically is going to be a negative because it is in the fourth quadrant. So in other words, this one's going to become negative tan x. Okay? What I'm going to do now is I am going to just go over to my step 2 as well. Let's reduce the other angles. So the 180 plus, that is in the second quadrant. And according to the cast diagram, sin is positive there. So I'm going to sit with positive sin x. I like to put my stuff in brackets. Then if I look at sine of 90 minus, now here I encourage you to go and watch my videos about the theory behind trigonometry. So what I like to do is the 90 tells me that I'm working with cos automatically. So I know that this is going to become cos of x. And because it is 90 minus, it's in the first quadrant, which means sin becomes positive cos x. Let me just put my brackets around my cos x. Okay? Let's have a look at the cos 110 degrees. Okay? Now at this moment of time, you kind of must decide, am I going to work with cofunctions, 90 plus or minus? I don't advise that. Personally, I would rather not do that. But this 110 degrees is 180 degrees minus 70, which means cos in the second quadrant is going to become negative cos of 70. Okay? And again, I just like to put my brackets there. Then I'm going to look at the bottom. Again, I've got 90 degrees, which is going to tell me that cos changes into its cofunction. So definitely it's going to become sin x. But now, 90 plus is second quadrant. And cos there is negative. Okay? So this becomes negative sin x. Let me just recap. The 90 changes cos into sin. The 90 plus is second quadrant. Cos is negative there. It doesn't matter what it changes into. The original function is negative there. So I'm going to sit with negative sin x. Okay? Then I'm going to also have a look now at the 160. 160 is also in the second quadrant. So I'm going to write 180 minus 20. And if I look at that, ladies and gentlemen, sine there is positive. So positive sin of 20 degrees. And there we go. Woo! Almost done. Almost done. Because that x plus 180 is still bothering me because it's not between 0 and 90. But now what I can do is this automatically shows me the x plus 180 that I'm working in the third quadrant. And tan is positive there. So I'm sitting actually here with just positive tan of x. Now I'm just going to rewrite the other ones over. That is sine of x. At the bottom, it is also negative sine of x and negative tan of x. At the top, I've got a cos of x. But now, ladies and gentlemen, I'm sitting with a nice little question here. Cos of 70 and sine of 20. please understand that we asked you to do it without use of a calculator. Now, the moment I hear without use of a calculator, I'm thinking special angles, first of all. If special angles don't work, I think about maybe try and get the angles the same. Oh, wait, that I can do. Because I can change cos of 70, I can change into a 20 degrees because of cofunction. So that becomes sin of 20, but it still stays negative. I don't do anything with that purple negative. It stays purple. Let me make it purple. There we go. So the negative comes from the top, that cos 110, it's negative. It's not because of it changing into some kind of special cofunction. No. Just cos 70 changed into sine 20. Now, the beautiful thing is that most of the time, it's going to divide away. Or as you guys like to say, cancel out. I hate that terminology, but it divides away. So sine 20 divided by sine 20 is 1. So they divide away. Now I'm going to divide away with the other things as well. So sine x divided by sine x. Tan x divided by tan x. So at the top, I'm left with a positive 1 times by a positive 1 times by positive cos x times by negative 1. Remember that purple, so negative 1. So if I multiply the top, I'm left with negative cos x. If I look at the bottom, basically the same thing happens. There I'm left with negative 1, I'm left with negative 1 and positive 1 because of the dividing away. So at the bottom, I'm left with negative 1 times by negative 1, which gives me positive 1. So in other words, I'm left with negative cos x over 1, which is just negative cos of x. Did I answer the question that they asked me? Always look back at the question. The question was, simplify the expression below to a single trigonometric ratio. Boom! I've done it. Now, I can move on to the next question. Always, and this is just my little bit of advice to you, is when you do any kind of exam, always look at whether you've actually answered the question or not. That is very crucial because I've seen many of my students. They run at a cheetah's pace, go, next question. But then they actually don't answer the full question. Then there's a lot of times 1, maybe 2 marks that they lose simply because they haven't actually answered the question the examiner stated. So please always refer back, did I answer the question? In this case, yes. So I'm going to go on to the next question. Now this next question, ladies and gentlemen, is all about trig graphs. Now I promised you guys I'm going to do a bit of trig graphs. So I'm going to tackle that first and get it out of the way. When I look at this specific question, also from St. Stithian's Girls, asked a year or 2 ago, the graphs of the function f of x equal to a cos bx and gx equal to c tan 2x for x between negative 90 and 90 are sketched below. The graphs intersect at the points p 29 degrees and, semicolon, 1,6 and q. That is shown on the graph. Now, please, and I encourage you, before you dive into the questions, let's first analyze. If I had to look at A and B, let's just start and ask ourselves, what would A and B do? If I look at A and B in this case, it would change the A would change the amplitude. Let me do it in green. I want to have a bit of green today. A would change the amplitude of the graph. And if I look at B, B would change the period of the cos x graph. And lastly, C on this side here would mean how steep the tan x graphs goes up. Okay? Now, tan x is always a bit of a funny bunny. Okay? Excuse my colloquial term, but it's a funny bunny because there's no amplitude to change. There's no highest point that changes. But what it does, it makes the graph steeper. So what I'm going to have a look at is, I'm going to look later on how do I determine the actual value of C. That's actually point B. Now let's look at what does that 2 change of the graph. That 2 changes the period. So in other words, the new period of the graph is the original period divided by that 2. Now, the original period for tan is 180 degrees. And if I divide that by 2, it means 90 degrees. So in other words, every 90 degrees, the tan x graph repeats itself. It's this whole circular repetition that happens. Now, if I look at the graph, it actually makes sense because my one graph goes from negative 45 up to 45, 90 degrees. In other words, the graph takes 90 degrees, to actually complete itself. Now, what I always like to tell my students, you know what? Let's go one step further, because I'm going to look at the steps now. Sorry, that's a real bad dad joke, that one. The steps is how many degrees, every how many degrees does something special happen. So now I take the 90 and I always divide by 4 because there are 4 quadrants. Every 22,5 degrees, something special is going to happen. Now, if you had to draw a graph, that's a little bit of a trick, is that can be your steps you put in, except for when we shift left and right. Then these steps don't always work out. Okay? So let's quickly have a look now at the actual questions that they ask me. First of all, write down the range of f. So in other words, if I look at the range of f, that means from the lowest y value to the highest y value. So from negative 3 to positive 3. That is my lowest y value and my highest y value. So in other words, my range of f is y is an element of negative 3 up to positive 3. The graph does reach negative 3 somewhere, and it does reach 3 somewhere. And that means from the middle of the graph to the highest point is 3 units. That gives me what of the cos x graph? Come on, ladies and gents. Amplitude. So automatically, I know what the value of A is, but we'll get back to that. Okay? Now, let's quickly look at question B. If m negative 2, 5, semicolon negative 1, lies on G, determine the value of C. Now, you can try and all your fancy tricks and fancy interpretations, etc., etc., etc. But I'm going to be lazy, and I'm just going to substitute it. Remember that from algebra. Functions and graphs. If you want to determine any variable's value, just substitute in. So in other words, y is negative 1 and x is 22,5 degrees. So I just substituted x and y into g of x. Now, if you put this back part in your calculator, or even without, 2 times by 22.5 is 45 degrees. Tan of 45 is 1. So in other words, I have on the right-hand side c times 1, which is just c. And the right-hand side, I've got negative 1. Okay? My apologies, I made a mistake. How quickly does a mistake happen? It's not 22.5. It's negative 22.5. So behind the c, that is negative 1. Oh, thank goodness I saw that mistake. Which means that c is equal to 1. Okay? Negative 1 equal to negative c, so therefore c is equal to 1. Okay. Interestingly enough, how did I see that I made a mistake? Okay. When I was doing the sum, I'm being very honest with you, as I was writing down the answer for c to be negative 1, there was kind of a bell going off in my head because I know my trig graphs. If a tan graph starts by 0 and moves up, it means the coefficient of tan has to be a positive value because it starts at 0 and goes up. If it starts at 0 and goes down, then it's a negative value in front of the tan. So in my head, there was these bells going off. Wait. But ladies and gents, that only comes from knowing your graphs well. Always remember, check your answers and study your graphs. Study your theory, ladies and gentlemen. Okay? Let's quickly go on to the next part of the question. If I look at the next part, remember what we have. I just want to quickly say the amplitude as being 3. And then I automatically have the value for A. Now I need to have a look at the value for B. Okay? Now to get the value for B, I need to actually determine the period of my cos x graph. Now, the way I'm going to do it for you in 2 ways. And you'll understand why as I explain it. The first one is see if I don't have a full curve that is sketched. If there's a full curve, there is. From that point there to that point there is a full up and down before it's going to go up again. So in other words, from negative 90 to positive 90 is 180 degrees. And that is my period. Okay? Ooh, let me write it a bit nicer. Sorry for the for writing it so ugly there. The period. There we go. But what if I don't have a full sketch? Because sometimes, as an examiner, we are sometimes just a bit nasty. Let's just say plain, outright nasty. Okay? Then what we sometimes do is we give you a part of the curve. We don't give you a full curve. And then we kind of go figure out the period. So what I like to do is I like to divide my curve into the 4 parts. So, for instance, where's the graph going down before it kind of, and then it kind of goes from concave down to concave up. Now, if you don't know what that means, it kind of just means when does it stop decelerating and start accelerating? Okay? I'm struggling to explain myself at this moment. But basically, if I look at this graph, it goes down there. And then at that point there, it kind of shifts gears and starts going there. So I like to kind of look at my graph and say from which point does it stop going down, decelerating. Okay. Let me rather stop the bus at the moment before I confuse you any further with my decelerating and accelerating. Look for the middle of the curve. That is maybe an easier way of doing this. Look for the middle of the curve. From the highest point to the middle of the curve is 45 degrees. That is 1/4 of a curve. From the top to the middle. That's always 1/4 with sin and cos. Now that is 45 degrees. In other words, 1/4 of the cos graph, the cos bx graph, so 1/4 is 45 degrees. So if I times both sides by 4, because I actually want one full curve, then one graph would be 180 degrees. And there, ladies and gents, I've got my period. That is if you are given a part of the curve. So always look for the middle. Okay? How long does it take from the top of the graph to that middle if it is a sine or a cos x graph? Okay? So if the new period is 180 degrees, then what I like to always do when I'm calculating B is I take the original period and I divide it by the new period. Because that shows for me how many graphs fit in to the original period. Now that is 360 over 180 because that's my new one there. And that means the B value is 2. An easy way of thinking about this is, if the period is 180 degrees, how many graphs would fit into an original 360 degree period? 2, so therefore B is 2. I hope it makes sense to you. So if this doesn't make sense in terms of how many graphs fit in, just go and learn the formula. The B value is the original period divided by the new period. So let's quickly have a look at question D. Without calculations, please determine the coordinates of Q. Ooh, that is a beautiful question. I love these kind of questions. Okay? Now, what I like to think of is, I'm just going to erase a bit of my green on the sketch, and I'm going to explain to you how I think about this. Remember, okay, this is 30 degrees from that starting point, that my graph, that is not 30 on the dot, 29 degrees, comma, 1, comma 6. The beautiful thing is, okay, that if I take a tan x graph and I take a cos x graph, it's repetitive. So in other words, it doesn't do erratic things all of a sudden. The nice little trick that I have learned is that 29 degrees is going to be the same from the middle of that. So from that 90, it's going to be 29 degrees that way. And then instead of going up, my graph goes down that same 1,6. So in other words, this Q value is going to be 61 degrees and negative 1,6 because the graph is repeating itself. Both graphs are nice, repetitive. They repeat every certain number of degrees. So the movement from the center of the graph to that top intersection at P, 29 sideways, 1,6 up, is going to be the same as from the middle, from 90 degrees now to the left and down. And that's it, 61 degrees and negative 1,6. And that's why they tell you, do not try and calculate. Again, look at mark allocation, 2 marks. So if you try and put those graphs equal to each other and solve, you're going to have a tough time with that. Okay? I know it's weird. That's why I'm doing it with you. So always look for those kind of repetitions where it goes. Okay. Whew, this is a fun sum. And that's why I'm doing it with you. Okay. So now I'm going to have a look at the next little bit of a question. The next question, ladies and gents, is looking at, that is the wrong question that I skipped on one too fast. Sorry, I don't want to give myself away yet. The next question says, if the system of axes is shifted 45 degrees to the left. Now that is a bit of a weird one. In other words, the y-axis is shifted left. So now there's my new y-axis. Okay? I want to ask you this interesting little question. What actually happened? So now I just want to say there is now the new 0 degrees. And there is now 45 degrees. What happened to the graph of gx or fx? Okay, let's look at f. Okay, I want to look at f. Let me quickly retrace my steps. I'm going to quickly retrace my steps. Let's look at the original graph's coordinates to help you. When I look at fx, this is at 0, 3. X is 0 degrees and y is 3. Now, if I shift my graph like I showed with the purple, the new set of coordinates, remember, now here is 0 degrees. There is 45 degrees. So this coordinate is now 45 degrees, 3. What actually happened to this set of coordinates to go from 0, 3 to 45, 3? The graph actually shifted right because it went from 0 degrees to 45 degrees. So here's an interesting little thing. If they shift the axes left or right, so they shift the axes 45 degrees to the left, it actually means my graphs shift in the opposite direction. So my graph shifts right 45 degrees. It's kind of, I shift the axis and my graph shifts in the opposite direction. Okay? And that's hopefully obvious if you look at 0, 3 becoming now 45, 3. So it went 45 degrees to the right. So now the moment I shift left and right, remember, fx is the graph. Let me quickly do fx fx was the graph 3 cos 2x. The moment I shift left and right, I shift by the x. And it's always opposite of logic. So in other words, by the x value, okay, I'm going to write all the other things the same, but by the x value, if I shift right, it becomes negative 45 degrees. Okay, let me maybe do that in a different color so that you see that's negative 45 degrees. Think about algebra. If I shift the parabola to the right, it becomes x minus. If I shift the parabola to the left, it becomes x plus. Shifting left and right is always opposite of logic. Remember that. Okay? Sure. This is a lot of fun. This is a really, really tricky question, and that's why I love it. If I look now at question F, determine the values of x for which fx times by gx squared. Oh my goodness, I've never seen this sum before in my life, so never. It actually made life very simple for you. You just don't really maybe realize it. Because when we do something like a function, something, times by something else being positive, I'm going to have two options. A positive times by positive, or a negative times by negative. Let me do it in the same colors. So I'm going to do that fx in purple, and I'm going to do the gx squared in red. So negative times by negative. Now here comes the interesting little thing. If I look at a square, what on earth is that square doing there? The square, remember, takes any negative and just makes it positive. So in other words, I don't care much about the actual value of gx, but it takes a negative answer and squares it, makes it positive. If it's positive, it's kept positive. So in other words, that negative times by the negative can't happen, because I'm not going to have g of x squared being negative. So in other words, I'm actually only looking at fx, because gx squared is always going to be positive. So I'm not really going to worry about g of x. It's always positive. So now I'm going to go to my fx graph, and I'm going to just erase my shifts here. I'm going to erase my shifts just so that I can look at the graph again. F of x, here it's negative, 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 up to that point there. Then it's positive, 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 all the way to that part there. Then it becomes negative, negative, negative. So where is my fx positive? Not there, 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 not there. So the only parts is between negative 45 and positive 45, and that is my answer. Between negative 45 and positive 45. Now, do they say equal to naught? No. So I'm going to do round brackets. If it was equal to naught, square brackets. Oh my good golly gosh. This was a beautiful question. Thank you, Synthithians girls. You guys gave me so many questions. Thank you so much for that. Ladies and gents, I know that you might not be used to this difficulty level when working with trig graphs, but please understand. Who says that you're not going to get it? You never know. My philosophy is prepare for the worst. If it is that bad, you're prepared. If it is much easier, well, you're prepared in any case. So always prepare for the worst and you will be prepared. Now, if you are struggling with one or two things, please get in contact with either your teacher, come in contact with me, or with the Junior Turkey team, and we will gladly assist you. Now, what we would like to do is, if you are struggling with the theory, in the link below, in the description, there is a link towards the Junior Turkey Mathematics theory booklet that I wrote. Please download it and make sure you get the theory down before you prepare for these exams. Ladies and gents, I'm going to look now. The next little question actually came from one of my previous videos. I said that in the video, I clearly stated I'm going to tackle this in the live stream. It's an equation where we ask you to solve for x. In other words, a general solution. So let's quickly go over to that question. And here it is on the board for you. Solve for x, where cos x times sine x is equal to cos squared x. Because it is a quadratic equation, I am going to get equal to 0. I wish I was in there with you to ask you this following question. Would you have done the following? In other words, would you have divided by cos x on both sides? If you are honest with me, I think most of you would have done that. Hopefully not most of you, but I've marked quite a few matric papers and I've seen many students do that. Please understand, if you divide both sides by cos x, I can maybe give you 2 or 3 marks out of 7 or 8 for this question. If you are lucky, I give you so much. I can actually, as a teacher, give you nothing. You're not allowed to divide by cos x. I would like you to think about why. So in other words, what I did was wrong, completely and utterly wrong. So what do I do? What should I have done? Well, it's a quadratic equation, so I'm going to get equal to 0. Because it is quadratic, I follow algebra. So in other words, I'm going to say, well, 0 is equal to cos squared x minus cos x sine x. Then I'm going to factorize. Take out a cos x common, leaving me with cos x minus sine x. And therefore, I've got two options. Cos x equal to 0 or cos x equal to sine x. Okay? Two very basic equations that I need to solve. I encourage you to follow the method your teacher showed you. If you do the whole thing of, if it is a cos x, if you do like there's a specific rule, then you follow that rule. If there's a specific rule for sine x and cos x, then you do that rule. If it's a specific sign for sine x, you do that. But please, I don't like that method because it doesn't always work so nicely when you are working without the use of a calculator. So what I'm going to do is I like to work with reference angles. Okay? With reference angles, I look at where is r cos of 0, which means where is the cos function equal to 0, and that is now at 90 degrees. And with cos x being 0, I kind of can go, well, positive or negative, your choice. I just like to work with cos is positive, and that is going to be in quadrant 1 and quadrant 4. So in quadrant 1, I've got x equal to 90 degrees plus k times 360. And then I've got in quadrant 4, I have x equal to, 360 minus 90 degrees plus k times 360. So that is 270 degrees plus k times 360. Okay. What did I forget? K must be an element of Z. Please don't forget that K must be an integer, because again, I don't want to add half a revolution. Okay, I don't want to add, actually not half a revolution, half a period. I don't want to add half a period. Okay, so let's quickly now have a look at the second one. And with this one, oh, this is one of my favorites. One of my personal favorites. Whenever I've got cos x equal to sin x, then I'm going to divide both sides by cos x. In other words, 1 is equal to sin x over cos x is tan x. Wait a minute, sir. Wait a minute. In the first question, I told you you're not allowed to divide by cos x. Now, halfway through the sum, I'm telling you, you have to divide by cos x. I want to ask you this question, but why? I would like you to think about that. Why is that like that? The reason is actually quite simple. Some of you, I know, would go, oh, sir, it's easy, you know. If I divide by cos x in the first step, well, I get rid of this whole cos x equal to 0. But there's actually a much bigger thing at stake here, which is one of the fundamental rules in mathematics, which is I'm never allowed to divide by 0. Now, if I look at this specific question, cos x equal to 0 is actually a possibility. And therefore, I'm not allowed to divide by it because I'm dividing by a possible 0. But what if I do with the sin x and cos x? Well, let's actually have a look at it. And I want to just maybe expand your mind a little bit on this one, okay? If I look at the original sin x graph, you know, it kind of goes like that. And let's look at the cos x graph. Just make sure that I'm drawing it correctly. Kind of goes like that. Where is sin x equal to cos x? Well, that is the points where they intersect. If I look at the cos x graph, y equal to cos x graph, that is that one there. I want to ask you this question. Let me quickly actually enlarge this. I'm seeing that I'm actually writing quite small on the screen. Okay. There we go. If I look at the sin x and cos x graph, where the two graphs intersect, is the cos x graph equal to 0? No. So therefore, I'm not dividing by 0. At the point of intersection, I'm not dividing by 0. So therefore, I'm allowed to do it. And that's the reason why I can divide by cos x, because I know it's not 0, and therefore I can divide by it. Okay. Now let's quickly go towards this tan x graph. Let's get my reference angle. Now, I'm going to actually not use reference angle in the strict calculator sense of the word. Which tan x, which special angle gives me tan x to be 1? Well, that is where those two are equal. Oh, and that's 45 degrees. So in other words, my reference angle is 45 degrees. The reason why I'm doing that is, ladies and gents, when you get to varsity level, the first year, you're not allowed to calculate in the exam in the calculus subject. So you've got to be able to use your special angles and figure out, which special angle will give me a specific value for tan, or for sin, or for cos. So when I look at this, tan x equal to 1 can only happen when the reference angle is 45 degrees. Now I look, where is tan positive? Well, that only happens in quadrant 1 and 3. But with tan x, I remember that I only have to do quadrant 1. So 45 degrees plus k times, not 360, 180 degrees. But the beautiful thing is, I've already said k is an element of z1, so I'm happy. And there I have actually solved it. Woo! This is I'm doing some awesome sums tonight. Some real tough, nice ones. You can expect this in the exam. Let's go over, because my time is running out. And I want to quickly do this next sum. Okay? Now, actually, ladies and gents, what I would like to do is, let me do the sum for you. Let me do it with you. And let's go on and let's see what I'm going to get at. If I look at this sum that I found in, I think it was King David's in Linksfield, this question came up. It says, given that 2 cos squared x is equal to 3 sin x, show first of all that the equation can be written as that. Okay, so I am going to have to try and get that into that. Now, what I like to do always, and my students in my class know this, is I like to always compare notes. Where am I? Where am I going? How can I get there? If I look at this, the 3 sin x is already there. So I'm going to leave it there. But now I need to change cos squared x into something with sin squared in it. Now the only thing that I know with a cos squared, for instance, is that cos squared x I can change into 1 minus sin squared x. I personally don't like this. I'm being very honest with you, because it makes my sum more complicated. But I don't have another choice, because I do have to change cos squared into sin squared. So I'm going to substitute that in. So I'm going to say, well, this is 2 times by 1 minus sin squared x. And I'm going to bring that negative 3 sin x over and make it equal to 0. Okay? So this becomes 2 minus 2 sin squared x minus 3 sin x equal to 0. And I'm going to times straight through by a negative, because why? I want a positive in front of the sin squared. So I'm going to times by a negative 1 on both sides. So this means that's going to become positive 2 sin squared x plus 3 sin x. Now, positive 2 times by negative 1 is negative 2 equal to 0. Woo! I've done this. I've done this. I love this. And I've gotten to where I want to go. Ladies and gents, I want you to buckle up. because I think I'm going to blow your mind and I'm going to do something you might never, ever, ever have thought about. Now, the reason I want to do this is I want to show you how, as an examiner, I can make life very, very interesting, i.e. very difficult for you. I want to share with you just a little secret, something you have to know. In paper 1, we are allowed to ask you paper 2 type questions, or paper 2 questions. In paper 2, I'm allowed to ask you paper 1 questions, but usually we keep it to 1, maybe 2 questions. So for instance, I've seen in a matric exam where in paper 1, they asked inclination angle, which is just the gradient of a line, but they mixed it up with paper 1. In paper 2, I have seen them bring in some interesting algebraic manipulations to actually get that right. So I'm going to just blow your mind with what I'm going to do now. And I am going to use the quadratic formula to solve this specific question because it is a quadratic equation. So let me quickly show you how to do it. Now, please, you can use factorization, okay? Please use factorization, but I want to share this because maybe, just maybe, you get an examiner who's really nasty and they ask you something to use a quadratic equation for. So let's do this, okay? If I look at this, I'm going to do 2 sine x squared plus 3 sine x, so minus 2 equal to 0. In other words, that is kind of in the place of x, and that is in the place of x. In the formula, ax squared plus bx plus c equal to 0. So in other words, a is 2, b is 3, and c is negative 2. And x is sine x. So in other words, if I go to the formula says x equal to negative b plus minus the root of b squared minus 4ac over 2a. So what I'm going to do is, in the place of x, I'm going to put sine x. In the place of b, I'm going to put 3. In the place of b, I'm going to put 3. A is 2. C is negative 2. And A is 2. This goes to then, if I use my calculator, it leaves me with sin x equal to, well, that's 9 squared plus 16, so 25. So I've got negative 3 plus minus root 25 over 4. Please use your calculator. So I've got sin x, let me just do this properly, sin x equal to negative 3 plus 5 over 4, or sin x equal to negative 3 minus 5 over 4. So this gives me a half, and this gives me negative 2. Automatically, ladies and gents, that cannot happen because the sin x graph only goes up to 1. The y value cannot be negative 2. Goes down only to negative 1. So, and if you try and get a reference angle, it will in any case give you that no, or math error your calculator would actually show you. So you know there's no solution for that. So if I solve this one, stick with me. I've got x equal to, my reference angle is 30 degrees, plus k times 360, because it's in the first quadrant. Sine x is positive. In the second quadrant, 180 minus that reference angle. So that's 150 degrees plus k times 360 degrees. Okay. Oh my good golly gosh. This is amazing. I love maths. I love maths, guys. Why can't I mix everything up? I mean, it's so much fun. Now, what I'm going to do as a last little bit for today, I know I'm going a little bit over the 1 hour. Please forgive me for that. But what I'm going to do is just look at the follow-up question on this. The follow-up question on this one was, hence, solve 2 cos squared 3y minus 10 equal to 3 sin 3y minus 10 degrees. Okay, wait. I see the word hence, which means I've got to look back to my previous sum. Now, my previous sum, I had 2 cos squared x equal to 3 sin x. So this means they are the same. X is just actually 3y minus 10. Now, if I look at the solutions for x was 30 degrees plus k times 360. And I look at the other x was 150 degrees plus k times 360. If I now substitute this x with the 3y minus 10 degrees, I've got a normal equation that I need to solve. Okay? And now I've got two separate general solutions. So I'm going to take the negative 10 over. So 3y is equal to 40 plus k times 360. And I've got 3y equal to 160 plus k times 360. And then I divide by 3 throughout. So y is equal to 40 degrees over 3 plus k times 120. Divide by 3, divide by 3, divide by 3. Y is equal to 160 degrees over 3 plus k times 120. And because they ask me for specific solutions, in other words, y between certain numbers, I'm going to have to choose values for k. Now, if you are well versed with your calculator, you put those into the table function. If not, like I'm a bit handicapped here, I don't have a calculator on the screen. So I'm going to choose by making k equal to 0. Then I'm left with y equal to 13,33, which is fine. If I make k 0, there I get 160 over 3, which is 53,33 degrees. That works out because it falls in my range, or in that domain between negative 180 and positive 180. Now I need to make, for instance, k equal to 1. And that gives me 1 times by 120. So that's going to give me 133,33 degrees. It still works out perfect. If I make K1, there 1 times by 120, I get 127,3. No, I am lying. 173,33 degrees. Also works out 100%, it falls inside that. Now, please understand we're just adding 120s. If I add more 120s, it's too big because then my y's are going to get to 250 and 290. So I'm not going to go further. What if I now start subtracting 120? In other words, what if I go to k equal to -1? Substituting in -1 there, I'm going to get y equal to -106,67 degrees. If I substitute -1 in there, then I get negative, let me just do my maths quickly here. I think it's -67 or 66,67. Now if I subtract another 120 there, okay, it's too small. So in other words, there are all my possible solutions that I can have. Whoa, this was a tough session. I did some beautiful mathematics, some beautiful trigonometry. Ladies and gentlemen, it was fantastic that you joined me. Thank you for offering up your evening. I hope it's helping you. Please remember to share this video. Anybody can look at this. I'm also going to share in the description some wonderful theory, not just the theory booklet, but also I'm going to share some practice sums you can go and do. Please share this with your mates. Remember to subscribe below. Hit that bell to get the notifications when we upload. Our next live session will be about in 2 weeks' time, where I'm most probably going to look at a bit of probability to do as well as some analytical geometry. I'm going to try and cover those both. I'm going to see maybe I just do probability in one series. But ladies and gents, have a beautiful, wonderful evening. Go and enjoy it. Go and practice and make the most of this exams coming up. I know it's been a tough year, but you've done well to get so far. Keep on and have a blessed evening. Cheers.